Okay, hi, can you hear me now? Can anyone hear me now? Can you hear me? Okay. Can you hear me? Yes, this should be good now. Okay, yeah, so sorry, I'm not very satisfied with the streaming software that I'm currently using, so I have to switch it up. So sorry, then I just have to switch to a Q&A session here instead of doing the live tutorial, because this way I cannot capture my screen. But sorry, I did prepare it, it worked, and now just before I started the real live stream, all of a sudden my none of my audio devices, not even my mic was identified by the software. It works everywhere else, not here. So here we go. So yeah, what could we do here? So possibly let's kickstart with some questions that may be interesting for everyone. Okay, so if you have questions, just put the questions please into the chat, and I'm happy to answer them. And up until now, then I am going to be at the next week at the OpenFOAM workshop. So if you're there, then you can just give me a shout out, a hello, and then we can chat if you want in between sessions. I am going to give a training session at the workshop with the title "How to Run Your First Simulation in OpenFOAM and also run it in 3D." So this is the tutorial, the very first tutorial that you may know, which was the elbow tutorial with the tree mesh, the quad mesh, and the refined quad mesh. And I'm going to bring this to another level where I'm going to run a 3D, snappy hex mesh, a 3D geometry also for similar elbow geometry, and then we will not only have the 2D simulation results, but also the 3D simulation results. And also I will give a presentation on my current work in fluid structure interaction of aneurysm modeling. Yeah, so I'm really looking forward to that. Hi, Franco. How are you doing? I hope you are doing well. I did receive your email and it is on my list, so thank you. This is going to be very good inputs. So for everyone else who is not Franco, he sent me an email with some suggestions in how to use WSL in the Windows subsystem for Linux in Windows 10, and I will find a way how we can incorporate it as a video or community post. Let's see what I can do with it. I still have to work through, but very, very good suggestions from Franco there. So thank you, Franco. Good. So if you just joined, unfortunately, my streaming software does not recognize my audio devices, so I cannot do the live tutorial this week. I have to find another way to find another software. So I'm going to do it maybe not next week, because next week is the workshop, but in 2 weeks then I will do the live stream. So I really apologize about that. But now I have a impromptu Q&A session. So if you have some questions, I'm happy to answer them. So there are some posts already. So maybe let's just say hello to Dennis. Hi, Dennis. Hi, Salih. Yeah, also hi, Franco. Hi, Siva Sankar. I hope I pronounced it correctly. I am a postgraduate in thermal specialization. Is there any research position under you? So Unfortunately not. I have my own company, and I'm working alone in that company, and I also have to find work, so I don't have open positions, and also I don't know of any open positions in Austria. Franco, I'm good, thanks. Hope that it helps some people. Yeah, I am certain that it will help. Today, if you noticed, I uploaded a video on how you can improve your work with CF Mesh, because if you know, it is advised to use the FMS format for the geometry input instead of STL files. But if you convert the geometry from STL to FMS, then in the FMS file in the top, your boundaries are set to type empty. And usually, and this is what I did for a long time, I switched it manually. And then if you redo your geometry and then run your mesh, the new geometry run mesh, then you have to rewrite this empty boundary condition each time. But there is an alternative to that, which you can add to system mesh dict, and then you don't have to do that step every time. So make sure to check out. It's a short video, and yeah, it doesn't qualify as a YouTube Shorts because there are some limitations on the resolution of the video. So it has to be so the width has to be smaller than the height, but that doesn't really make sense for tutorials. You may have noticed that some of the short videos have that format, but I'm not a big fan of that. So I just do these short videos, and then I don't care whether they are considered to be YouTube Shorts or not. Okay, hi Muli. Then maybe did you watch? Maybe you can give me some feedback on last week's tutorial, live tutorial with the meshing. Did you manage to run it? Did you try it? Did you download it? It is in the download link is in the download in the description box below the last live stream, so you can download the zip file and then unzip it and then play around with it. So I hope that some of you were able to download it and play around with it. Okay, hi, Yunus, Emre. How are you doing? I hope it also helped you how I approach 2D cases where it would be difficult to apply block mesh, because there is no real measure, 2D measure for OpenFOAM. Of course, there are Salome and these kinds, but those are really geometric software, and this is the best approach that I found how I can do it in Blender and export it as an object file and then extrude one layer. Okay, so hi Shri. Have you ever tried running a multiphase fluid, liquid and solid, like a slurry inside a thick walled tube where heat transfer is from wall to the fluid? No, I have not. There is a solver called drift flux foam, which treats such problems on a macroscopic scale. So there are not individual solids. I would advise you to look into the CFD-DEM coupling of light with lights. So OpenFOAM and lights coupling, just Google it, and then you will come to the CFD-DEM homepage. That might work for you. Hi, Ular. Hi, I'm a graduate student working on modeling of pollutant dispersion in urban environments. That is a very interesting topic. Street canyons, buildings. I'd like to select an optimal heat transfer solver for my problem. So usually I would say for urban environments, it's best to start small and simple. So buoyant simple foam or pimple foam is maybe the way to go, or buoyant Bussinesque might also work for you. Yeah. So for heat transfer, if you want a real dispersion of species, then you really have to go for the combustion solvers, and then just get rid of the combustion models and then use the species transport. Okay, music lover. Hi, music lover. I'm new to CFD. How do we validate results after simulation? For that, usually you have experiments. Otherwise, you have to trust the software. Franco, Joseph, would it be possible to explain the use extra STL surfaces to create baffles with Snappy for creating the boundaries for rotating machinery, cyclic AMI boundaries? So yeah, I do have a tutorial on that, an AMI tutorial. So I'm not sure whether you want a tutorial and then explain, or just explain in detail how that step of converting baffles to Snappy works. So please just comment further below. Then Pramod Jathav. Hi Pramod, can we do volume mesh in Blender? No, that's the big drawback of Blender. If that was a thing, then I would only run my create my meshes in Blender, in my 3D meshes. But I mean, there is a very simple 3D mesher for volume renderings, but that's not something that you can export to OpenFOAM, and it is very similar to block mesh. So no, only surface meshes. Sorry. Yunus Emre, I just want to ask a question. I could not find it on Google. I am trying to run Sandia D-Flame tutorial cases, a large eddy simulation. Yeah, so there is the Sandia flame, and all you have to do is change in constant turbulence properties, the RAS model to LAS, and then you need a different turbulence properties entries. Check out my turbulence my turbulence tutorials in the advanced playlist, the advanced tutorials playlist, because I'm not doing the Sandia flame, but I'm doing a flow where I'm first running an RAS simulation, just like the Sandia flame is in OpenFOAM, and then in another video I'm doing an LAS simulation, and there you see the differences. Well, it's just syntax setup that you have to change. It's not a lot of differences. So just check out those two videos. My question is that in PRSR model, what is the C mix coefficient? Or whether this is very, very in depth. The C mix, that is a mixing coefficient that I have to check it myself. So let me just check this on my PC, because I do, and now it is a real shame that I cannot use my software, because it would be awesome if I could just stream my screen here, but oh well, we have to live with that. So let me just bring up here my information on the PASR, the partially stirred reactor model. Is this the correct? No, I don't think so. Maybe this is it. Okay, so theory combustion models, yes, this is it. Okay, so for the PASR model, what you do is you have two timescales. You have the chemical timescale that is calculated by OpenFOAM, and the turbulent timescale. And you scale your heat release rate of your fire with a constant that is kappa, and this kappa is then the chemical timescale divided by the sum of the chemical timescale and then the turbulent timescale. And the C mix is the constant for the turbulent timescale. So you take your turbulent viscosity, you divide it by the dissipation rate, then you take the square root of that, and then you multiply it with this C-mix constant. So what does that mean is that somebody came up with that idea of this partially stirred reactor. They experimentally fitted the curves and they didn't fit. So they introduced a magical constant C-mix, and this is usually 1 or 1.5. So it is just a scaling factor for your turbulent time scale compared to your chemical time scale. So I hope that answers it. Okay, so this is the C-mix. Hi, Ular. Would you please discuss the difference between buoyant simple foam and buoyant pimple foam? Buoyant simple foam is a steady-state solver of buoyant pimple foam, which is the transient version. So this is the only difference, that there you would run it just like simple foam, a steady state simulation, and you would run in pimple foam a transient simulation. Music lover, can you have a new video on running parallel simulation on newer versions of OpenFOAM, or the old one is enough? Old one is still valid. One thing that some people don't realize, don't use Scotch. It is very easy to use. You just type in Scotch and then decompose par. But especially in volume of fluid simulation, the processor boundaries, the boundaries between the CPUs can be odd, and you can lose water throughout the parallelization. So don't use Scotch, and watch out with simple, because with simple you can end up with 0 cells on some, depending on your geometry, you can have 0 cells on certain processors, and then your simulation will crash and you have no idea why. So this is what I can say, but the basic idea is still the same. Anuj, hi Joseph, do you think there is a possibility to generate castellated and snapped mesh in Snappy Hex Mesh and followed by adding the layer using CF Mesh? Not to my knowledge. I don't think that, because CF Mesh, you could try it. If you start at a certain stage in CF Mesh, if you can achieve it, possibly. What I can maybe advise you, I did mention that in my previous live stream, is that if you generate your geometry already a bit bigger by the size of the layers that you want, then what you can do is just generate your Snappy Hex Mesh without layers and use extrude mesh to extrude out your layers manually with extrude mesh. This works in some cases where the geometry allows it. So it may not work in some geometries, but it can be a good hack for some cases. Dennis, my question is, can I use a row const as a thermal for? Dennis, what was your question? In CHT multi-region foam, can you use row const for fluid region? It depends which kind of material you want. For a liquid like water, sure. Atiam, message retracted still. Welcome, Atiaman. I hope that's correct. Franco, did not know about that tutorial. I will have a look. I am curious about the steps to create a wall mesh with Snappy and then create. Yes, so it is on the tutorial wiki, and it is also an official OpenFOAM tutorial. It is in tutorial, incompressible, RAS, and then rotating fan in room. I think it's it should be there in version 2012 out of the box. With OpenFOAM, we can calculate the heat transfer coefficient for a surface, but we cannot calculate the heat transfer coefficient for the average cell temperature in a given area, -1. What? But we cannot calculate the heat transfer coefficient for an average cell temperature. Sally, I'm not sure what you mean. Could you please elaborate on that? Because unfortunately, I don't understand your question. Okay, so hi, Ivan. Hello, Josef. Do you mind to create video about solvers, Piso, simple and pimple, how the algorithms work? Make some examples. Could be a possibility. I mean, I just mentioned the differences. So Piso and Pimple are almost the same. It's just one small numeric difference. So there is no real difference. I think Piso is not needed anymore. Pimple is just fine. And the difference between simple and Pimple is that the one is transient and the other is simple and is steady state. But the algorithms are all the same. If you need a very good explanation how this all works, there is the PhD of Professor Ryova Yasak, where he explains you the numerics. So if you cannot wait for a tutorial video, then you can check out the PhD of Professor Yasak. Salih, I'm using ParaView for this. Is there a way to do all this using just OpenFOAM? Okay, so to the heat transfer coefficient on a surface. So cell. So I'm not sure how you could do that in a cell. So sorry, possibly the ParaView is the only way. Okay, so Franco, for wall meshing, you have Salome. You should try it, Joseph, especially next version is you have multi-threading volumetric mesh with NetGen. Yes, but NetGen is tetrahedral, isn't it? Or can it do hex? I mean, if you have something that you can send to me that where I can just take a look at it and it's just click and it is a good hex mesh, then I'm all open. Hi Atiyaman, hello Joseph, do you have tutorials on phase change material? No. Phase change is difficult and I've just touched it on the site, so unfortunately no. Nispru retracted his message, so still hi, Nispru. Hi, Helena. I hope that's the correct way to pronounce your name. Hello, sir. I'm beginner to OpenFOAM. Are you suppose that I need to refer theory of CFD before going to simulate? So what is the best reference to understand theory in CFD? There is a lot. There is a lot out there. So you can check out the PhD of Professor Yassar, just as I mentioned, the PhD of Hendrik Rusche, or check out one of my short videos there on my channel. It is called, what is it called? OpenFOAM Technology Primer, now under CC. So the OpenFOAM Technology Primer is a book that was released a couple of years ago. It deals with CFD, especially with OpenFOAM. And I bought that book and I read that book. But a couple of weeks ago, the authors released the PDF version for free under the Creative Commons license. So check out that video on my channel and download that PDF because that is a very, very good introduction. Okay. So, and maybe as a side note, please like the stream, it helps out a lot, and like my videos and subscribe to the channel because it increases also the visibility for others, and that helps me and helps others and helps you. So thank you for subscribing and liking the videos. SIGPE error, any advices to solve this error? I encountered this running SIGFPE, I'm not sure. So this might be segmentation fault. That can be a division by 0. Usually with the K epsilon model, you can have problems where this might be a problem in the mesh quality. I'm not sure. I'd really have to see the entire error message. Franco, so what method do you use for decompose bar? Yes, hierarchical is my go-to method. I mean, Scotch may work for simple foam. for pimple foam, but I'm working a lot with interfoam and interisofoam, and there you lose a liquid phase fraction, and that's just a no-no. So a hierarchical is a smart method, so you will not end up with 0 cells on the processor. So I think it's the best. Pranav, hi Pranav, I'm facing divergence issues in simple comb parcel foam. Yeah, that is a very specific solver, and specific solvers are problematic sometimes. Particle radiation. Can you point out any input code changes that can help address the issue? Input values given are correct. So yeah, this can be a mesh problem, but in these very special solvers. So for example, I tried out non-Newtonian models with the viscoelastic Maxwell model, and it crashed, and then I just found out that the implementation of the Maxwell model is rather unstable, and so you cannot really do anything about it. So it can be a mesh issue, but it also can be a thing that they implemented models which make some implicit assumptions which are not mentioned anywhere in the source code, and your problem doesn't meet those assumptions. So you have to really check out the source code, the models, and then review the problem. Camilo, hi Camilo. I'm a beginner to OpenFOAM. So everyone out there who is a beginner, welcome to my channel. I'm happy that I can help you, so just check out my videos. I tried to use SnappyHex mesh for refinement in some regions, but OpenFOAM can't read STL file. Then what is the best way to export the STL file? I do have a video on that, on how to export STL files. It is a short video. It is called, so from Blender, this is how to hack Blender for OpenFOAM shorts, how to use Blender like a pro for OpenFOAM. So check out those videos on that, how you can export STL in Blender. Yeah, I hope that helps. So Yunus, dear Joseph, me again. Sandia Flame LAS case in FV solutions, what I write on momentum predictor, yes or no? Momentum predictor is whether you want to explicitly solve the Navier-Stokes equations, or whether you just want to explicitly update your velocity. I would say you put it to yes. If it is unstable, you could try no, but no is usually only valid for high viscosity flows. So I would put it to yes. I ran out of fuel. What is the safest way to go back to 2134? I don't know. Okay. Hi, Manos. That's different. What's the difference between LAS and RIS around simulation? So arounds, I do have videos on that. So in the CFD intermediate, so it's not called advanced, it's intermediate playlist. I have videos on the difference between LAS and RIS. So in the short terms, in RIS, you assume that your models average over the turbulent oscillations. And in LAS, you assume that you depict some turbulent oscillations with your mesh, and you only model the turbulent oscillations that are smaller than your cells. So usually, from a simulation point of view, for run simulations, you can have a coarser mesh. For LAS, you have to use a rather fine mesh. Sally, thanks a lot. You are welcome. Günther or Gunter, I'm not sure. So hi. Hello, Mr. Notch. How long can it take to become a proper OpenFOAM coder if you have already some background knowledge in CFD theory and C++? I wouldn't say a couple of weeks, but half a year. It depends how much time you can spend on it. If it's just something that you want to do on the side, then it takes longer. If it's, for example, a PhD and that's your full-time job, then you can you can come along, especially if you use something as a template, or you have a starting point and you just derive from that. Then you can, within a couple of months, you can be a proper OpenFOAM coder. Also depends on where you want to code. Thermophysical properties, horrifyingly complex. Viscosity problems, boundary conditions are rather simple. NISPRO, I ran RAS and I was getting SIGFP error. I'm very sorry, I do not remember what. There was a printing stack error. Yeah, so mesh quality, possibly epsilon or k are not initialized correctly, so you may have to increase your k or epsilon or lower. Maybe you have maybe you don't use 0 as initial values, but non-zero values. So these are ideas that could help you. No physical models. I'm not sure about that. So hi, Nikolai. Have any opinions on row central foam? I did try it during my PhD, but never afterwards. So yeah, for highly compressible flows, it may be a good idea, but as far as I understood, it still needs a bit of improvement. So I would love to see a proper compressible solver which does not use a density-based solver. Because raw pimple foam and raw pimple foam are fine for slightly compressible problems, but for supersonic flows, they are not adequate. And I'd love to see a solver, an openly available solver, which can handle these kind of problems. And I know that multiple people already programmed it and validated it, but it's at the conferences they say that they will make it public, but they never do. So yeah, so it is a decent solver in my opinion, but it still needs improvement. Pranath, thanks for the answer. In fact, I have modified simple parcel form code as it wasn't working earlier and now stuck with it for some time. Effective code analysis. Debugging is always a very good idea. But what I usually like to do is, if you have multiple variables, then just fix your variables and change one. So for example, if you have the temperature as an input for something, then just switch off your temperature equation and use a constant temperature and see whether that causes your problem. Or if you have something else, the viscosity is an input to another model, then just use a constant viscosity instead of a temperature dependent. So just reduce your problem, your physics to the individual inputs rather than everything combined all at once. Kartoffel and in CHT multi-region simple foam case with 60 plus regions, my maximum was something with 260. One fluid region, flow convergence fast, but temperatures are taking forever. Is there a way to speed up temperature? No, because there is a numeric limit to that. And I know I just had a project which is very similar. It was not 60 plus regions, but only 20, but I had 40 million cells. And it took a long time. So not with the CHT multi-region simple foam. In foam extend, there is an alternative solver, and I don't know the name of it. Foam extend CHT. What is it called? I don't know by heart. How to contribute. Just give me a second. Possibly I can find something. Solvers, heat transfer, CHT multi-region foam. No, I'm not sure, but in foam extend there is a coupled CHT solver, which couples the temperature equations and then solves everything all at once and not sequentially, and that is supposed to be faster. So you may check out that solver, but unfortunately I don't know the name by heart. It's in foam extent, so it's not in the .org version or in the .com version. It's in foam extent. I'm trying to run simulation using Interfoam, but the solder doesn't appear in directory. Is it a separate module I should install? Interfoam? No, it should be out of the box. Check out my multiphase simulation project. There I use Interfoam, and there you can see how you can run Interfoam. Siddhartha, hi. Hi, Vinicius. Could you teach drift flux tutorial? Do you have any tutorial about? No, I don't have it. I use it in a project. There is one tutorial. It is very similar to Interfoam with small differences. The thing is, it is a very niche problem, and if I bring such niche problems to my channel, there are maybe a couple of people who are interested in that, and then 99.9% are not really interested in that. So if you have some issues, then I'm happy to answer them in a comment section somewhere on YouTube below the video. Drift flux from Danny. Speaking of PCM, my question is: can we somehow successfully run a simulation with using of enthalpy porosity method? I'm not aware. Sorry. David, can you simulate high viscous flows such as hydrocolloids through ultrafiltration? High viscous fluids depends on what, is it constant viscosity or is it a non-Newtonian? I'm not familiar with that problem. You can run highly viscous fluids, also non-Newtonian fluids. So if you could just elaborate on the model, then I can answer. Vinicius, you're a beginner. You are welcome to my channel. Pranav, you're welcome. Fabio. Hi, Fabio. Any suggestions on appropriate decomposition methods when using AMI patches? Usually, the usual to have I mean, if you can put your AMIs onto one CPU, that's great. Usually, you cannot. Then try to have as few communication phases between the CPUs as possible. And distribute the number of cells evenly, so so it doesn't happen that one of your CPUs does all the work, and then the other ones are waiting for that one CPU to do the calculation. I hope this helps. Camilio, thanks a lot. And I have other questions. Sure. How to give permission to OpenFOAM to read STL file with VSL, because when I want to read content to STL file is nothing. Possibly your problem is that you exported it as a binary file. Usually STL comes in two flavors, ASCII and binary. You may have to make sure that you export it in ASCII. Maybe that's the problem. But if it's empty, then something went wrong during export. So it is really empty. If it's just gibberish, then it's a binary file. So just re-export it as an ASCII. Or alternatively, you can import it in Blender and then export it to this as an ASCII file in Blender. Kartoffel, thank you, sir, also for doing all these awesome tutorials. You're welcome. Okay, Tilina, thank you. Got that PDF. Great. Thanks a ton. Do you think Ron Turek is a very good benchmark in terms of detail for FSI, or which kind of problem? I guess so. It is a very, very, wow. From the numerics and physics point of view, that's quite something. So yeah, I wouldn't do it as a first example because it is very involved from the physics point of view and also from the numerics point of view. I mean, it is geometrically rather simple, but from the detachments and the flapping around, that is quite something. So it is as a last benchmark case in a work, yeah, but I wouldn't start with that because that is a complex problem. Okay, so if you just joined the stream, I know I wanted to do the live tutorial, but my streaming software didn't work, didn't want to recognize my audio equipment, so I have to switch to a Q&A session, but sorry, but this is just how it went today. So hi, Boris. I see you a lot on LinkedIn. Thanks and congratulations on your work. So I do see what you're doing. Hi, Joseph, thanks a lot for your kind contributions for community. You're welcome. But I know that you also do quite something for the community. So also thank you for that. Okay. So if you have some questions, then just put it in here. Maybe I wanted to tell you something. Yeah, so I hope you like these live streams. I mean, this was impromptu, but I like the way to this way to interact with you and also set up something and get feedback. So if you like it, then you just tell me. If you don't like it, then please also tell me. Okay, so Dodamani, hi. Thanks for all your work. I wanted to know our planning for a C++. What? I wanted to know our planning for a same on C++. I'm not sure what you want to ask. Maybe whether I want to create tutorials on C++. Well, no. Go to wiki.openfoam.com/tutorials. Okay, so wiki.openfoam.com/tutorials, and then go to contributions by topic, and there are programming tutorials for OpenFOAM. Just check out those tutorials. So C++ for 3D which not found. You're welcome. Okay, then maybe let's wait a little bit for possible questions, and if not, then I think we can call it a day. As you can see, my background is different because I'm in my new office in the new headquarters of Fuellarian Solutions. I'm almost moved in. There are a couple of boxes left, but now everything should work. And I think that the light is okay. I know that this is a bit dark, but I still have to work out the best possibility. In my last office, I already had a better solution, but yeah, this is a working process, setting up my new office. Okay, so then if there are no questions, then I will let you know about that live tutorial session, because I would love to do it next week, but next week is the OpenFOAM workshop at that time. And so I'm not sure whether I can do it. So I think it's going to be in 2 weeks. So I apologize for the delay, but yeah, blame Streamlabs OBS because the software didn't recognize my audio equipment. So I will let you know. Up until then, I will community posts just to interact with you. There are a couple of very interesting posts, so make sure to check them out regarding the usage of OpenFOAM and stuff like that. And I really like the mystery of the week, so check them out on Friday. What you think, what I'm doing each Friday. And if you like to support my channel, then please go over to Patreon. There you can join me as a Patreon. You can also support me here on YouTube in these live streams. There is the super chat. So if you want to support me, you're very welcome. You don't have to, of course. And you can also help me by subscribing and liking the video. So with that, I would like to thank you for watching and listening, and I hope to see you next time.